All right, so today we're going over conditionals and data structures part 1. Let's get started. So conditionals. So there are a few different ways you can create a conditional, but generally the thing they first require is this if. So in a conditional, you'll have your if first. If is your keyword here. So you can't have like a variable or anything named if. This has to be this is a reserved keyword in Python. So you would do if first, and then you'll have a Boolean value following the if. So this can be a single Boolean value. So right here, I have a variable named Boolean1 that's storing a Boolean value, or you can have a Boolean expression. So down here, I have the Boolean expression of Boolean1 or Boolean2. So remember, as mentioned in last week's lecture, you can chain together Booleans, or you can chain together expressions and create a Boolean expression. So this is what's called a Boolean expression here, because we're checking the truthiness of Boolean1 or Boolean2. Yeah. So in this first one up top, so here I'm just checking if Boolean1. So if the value stored in Boolean1 evaluates to true, then what's going to happen here is we're going to print Boolean1 is true. Otherwise, if the value of Boolean1 evaluates to false, then nothing will happen here. We won't print Boolean1 is true, and we'll just skip right to line 6, basically. So you'll see the line numbers over here. So yeah, and just once again, the syntax, you start out with if, then you have your Boolean, and then you have a colon, and then tabbed underneath that. So this is very important. The indentation is extremely important in Python. So indented underneath my Boolean expression is where I have print Boolean1 is true. So only if the value stored in Boolean1 is true, or it evaluates to true, will line 5 actually print out to our console. And then for line 7, here we're creating a Boolean expression instead of using a single Boolean. So here we have if, and then we have Boolean1 or Boolean2. So remember, or is one of our logical operators. And here we're checking if Boolean1 or Boolean2 is true. So remember from last week, as long as one of these values is true, the entire Boolean expression will evaluate to true. And in that case, so say Boolean1 is true. So if Boolean1 is true and we run this code, first we're going to get Boolean1 is true printed to the console, and then we'll get in this Boolean expression, because Boolean1 is true, that makes this whole Boolean expression evaluate to true. And then we get, at least one of Boolean1 and Boolean2 is true. So here we don't necessarily know which one is true, Boolean1 or Boolean2. One thing that we can tell is if Boolean1 is true was printed because of lines 4 and 5, then we know that at least Boolean1 is true. But but when line 8 also prints out to the console, we don't yet know if Boolean2 is true, because remember, with an or operator, only one of them needs to be true for this whole Boolean expression to evaluate to true. The only way that line 8 wouldn't print to the console is if both Boolean1 and Boolean2 had values that evaluated to false stored in them. So yeah, another conditional that we can do is an if else. So up here, if the Boolean expression evaluates to true, then we print whatever is indented underneath that if. But if that evaluates to false, then we just do nothing with this if up here. We just don't print out Boolean1 is true, and then we just skip to the next one. And if nothing happens here as well, if both Boolean1 and Boolean2 are false, if that evaluates to false, then we don't print anything here either. But say we have a scenario where we want to print something or do something in the case that some Boolean or Boolean expression is true, and then in the case that it's false, we want to do something else, then that's where the if else comes in. So here's the syntax for if else. So you start out with your if, just like in the simple if up top. But in the if else, then you'll also have an else colon after the code block that's supposed to execute in the case that Boolean1 is true. And then again, indented underneath that. So tabs and indentations, very important in Python. Just want to reiterate that again. This space here is very important to have it indented. You'll get errors if you don't have it indented properly. So yeah, We have our else colon, and then we have what happens in the case that the Boolean expression in our initial if evaluates to false. That's what happens in the else block. So this is like a catch-all block. So up here on line 10, we have if Boolean 1, and sorry, one moment. Looks like a few people are joining right now. All right. So oops, let me go back. So here on line 10, we have if Boolean 1. So let's say that the value stored in Boolean 1 is true. Then we print out Boolean 1 is true, and we skip the code that's in lines 12 and 13. So we don't print out Boolean 1 is false. But in the case that Boolean 1 is false, then this Boolean expression up here evaluates to false. We don't execute the line of code on line 11. We go to our else block, which is like our catch-all. So if nothing above it had evaluated to true, then we go to the else block. So in that case, we would print out what's on line 13, which is Boolean 1 is false. So in this case, we'll basically understand whether or not Boolean 1 is true or false, and that will be printed out to our console here. Any questions on if and if else?
Yes, please, I have a question.
Yeah.
On line 4, if Boolean 1, and it's just blank, it's not stating it's true. So how do we, I think we are assuming that statement means if it's true.
Yeah, exactly. So we don't necessarily know what's stored in the value Boolean 1 right now. And that's partially why we're using the Boolean expression here, right? And why we're using this if conditional is to have different behavior based on whether or not Boolean 1 is true or false. But this is just a variable here. So up on lines like 1, 2, and 3, you could imagine up here, I had created a variable called Boolean 1, and in it is stored something that evaluates to either true or false. So it could be the raw values true or false, or it could be a Boolean expression that evaluates to true or false, things like that. So in this case, we aren't explicit about whether or not this is true or false, but depending on what's stored in that variable, that's how it'll decide the behavior of whether or not it prints Boolean 1 is true or it doesn't. Does that help to clarify things a little bit?
Okay, thank you.
Yeah. Cool. And I'm not seeing any questions in the chat, so I'm just going to keep moving along. But yeah, if you have any questions at the end of each slide, feel free to come off mute or put your questions in the chat, and I'll come around to them at the end of each slide. So now we have another if construct, another conditional construct that we can use. So in this case, it's called an IfElif else. So we have our normal if, where we just check if whatever our Boolean expression might be. And in this case, we say if Boolean 1. So if Boolean 1 evaluates to true, then we print Boolean 1 is true. Who knows about Boolean 2 though? So in this case, if Boolean 1 is true, then we just print what's on line 16, and then we're going to skip to line 21. So the way conditionals work, they'll go through and they evaluate the if, then the elif, then the else. As soon as one of these evaluates to true, it skips the rest of the conditional. So in this particular case, say Boolean 1 is true, we evaluate if Boolean 1. So say the value stored in Boolean 1 is true. So again, so with Boolean 1, this is basically a Boolean variable. And remember Booleans from last week, a Boolean is a value that stores either true or false. So if Boolean 1, so if it's true, then we print Boolean 1 is true. Who knows about Boolean 2 though? And then we're going to skip to line 21 because we're going to skip the rest of our conditional expression at that point. But say Boolean 1 is false. If Boolean 1 is false, then we're going to skip to line 17 and we're going to evaluate Boolean 2. And that's what our elif is for. So this makes it all part of the same conditional statement by using elif instead of a separate if on its own. If we did a separate if on its own, then they would be evaluated sequentially as opposed to evaluated only in the case that the one above evaluates to false. So Boolean 1 is false, we skip to line 17, check if Boolean 2 is true. If Boolean 2 is true, then we say Boolean 2 is true. Also, we know that Boolean 1 is false. And the reason we know Boolean 1 is false is because we made it to line 17. We only evaluate line 17 in the case that line 15 evaluates to false. But say that both Boolean 1 and Boolean 2 are false. So if Boolean 1 is false, we don't print line 16, skip to line 17, evaluate our elif boolean 2. So if elif boolean 2 is false, then we also skip line 18 and go straight to our else block. The else block is like a catch-all, and it only evaluates in the case that everything above it has evaluated to false. So in this else block, we would print boolean 1 and boolean 2 are false. And we know that because the only way we get to line 19 and 20 is if boolean 1 and boolean 2 have already both evaluated to false. We can also chain together multiple elif statements here. So say we wanted to say, so up here, we don't, if a boolean 1 is true, we don't know about boolean 2 at all. So say we do want to know about boolean 2 and we want to print something out in the case that boolean 1 and boolean 2 are both true. So here we're going to take our two separate booleans and we're going to put them into a Boolean expression using our logical operator and we're going to check if boolean 1 and boolean 2. So if both boolean 1 and boolean 2 are true, then this whole Boolean expression will evaluate to true. And then we'll print both boolean 1 and boolean 2 are true. We skip the rest of the conditional and go to line 30. But say one of boolean 1 or boolean 2 is false, or both. There's no way to know at this point right here. So if one of those is false, this whole Boolean expression will evaluate to false because remember an and requires that both the conditionals or both the Booleans on either side of the and operator need to evaluate to true. So say that they at least one of them is false, then we're going to come to line 24 and check our elif boolean 1. So elif boolean 1, if boolean 1 is true, then we would print boolean 1 is true and boolean 2 is false. The reason we know that boolean 1 is true and boolean 2 is false is, so first off, for boolean 1 being true, the only way that line 25 executes is if boolean 1 is true. But the only way that we get to line 24 is if boolean 2 was already false because this whole Boolean expression of here of boolean 1 and boolean 2 evaluated to false. So we come down into here and then we would print boolean 1 is true and boolean 2 is false. So now let's go the other way around and say that boolean 2 is true, but boolean 1 is false. So on line 22, we have boolean 1 is false and boolean 2 is true. So when we and that together, because we have false and true, we get false. So we skip line 23, go to line 24. We check our elif boolean 1. We're checking the truthiness of boolean 1. It's false. Because it's false, we skip line 25, go to line 26, and evaluate boolean 2. Now we're checking elif boolean 2. Boolean 2 is true, so we print boolean 1 is false and boolean 2 is true. And again, we know that because the only way we get to line 26 is if line 22 had evaluated to false in some way. And since we're anding these two together, that means at least one of them must be false. Cool. And then say both of these values were false. If both of them are false, then we check boolean 1 and boolean 2. When you and together two false values, you get false. So we skip to line 24, check the truthiness of boolean 1 in our elif boolean 1. That's false. So we skip to line 26, check the truthiness of elif boolean 2. That's false. So we skip to our else block, and then we print to the console both boolean 1 and boolean 2 are false. So the only way that we get to this else block is if everything above it has evaluated to false so far. Cool. So it looks like we have a couple questions in the chat. Sorry, I can't comprehend the Boolean statement. How do we know the clause is 1 and 2? So here, give me a moment. I'm going to answer the questions in the chat first, and then I'll go to people who have who want to come off mute to ask a question. Okay. So sorry, I can't comprehend the Boolean statement. How do we know the clause is 1 and 2? So if you're talking about this particular line here, the reason we know it's 1 and 2 is just because of the and operator here. But keep in mind that these variable names are completely arbitrary. We can give a name to any. We can name a variable just about anything as long as it's not a reserved keyword in Python. So like in this case, if, elif, else, those are reserved keywords in Python. So we couldn't call a variable if, elif, else, or and, or anything like that. But these, oops, let me go back, sorry. But these variable names are completely arbitrary. They're just pulled out of thin air. Boolean 1 and Boolean 2, they have no meaning in and of themselves. It's all what is stored in that variable. And remember from last week that variables are what we use to store raw data, to store data basically in Python. So whatever is stored in Boolean 1 and Boolean 2 in all the examples that I'm doing here is just some value that evaluates to true or false, or are the raw values true or false. So yeah, I hope that answers your question. I guess I'm not too sure if you're asking about the variable names themselves, or if you're asking about how exactly the Boolean expression here works. So if I didn't answer your question, please ask a follow-up in the chat. Hi David, could you give us an example of what is stored in Boolean 1? Yeah, so in Boolean 1, say that's stored in here is just the value true. So it's just the Boolean data type true. That's all that's stored in Boolean 1. And then another example could be the raw value false. The raw value false could be stored in Boolean 1. Another example could be like, is 5 less than 6? So if we set, Boolean 1 equals 5 less than operator 6, then that's a Boolean expression, which will evaluate to true. So now the value true is stored in Boolean 1. So there's a number of different things that we could store in Boolean 1. We just need to make sure that it's something that can evaluate to a Boolean. Another example of things that could be stored in Boolean 1 is like, say you have a string. So an empty string always evaluates to false, but a string with a value in it always evaluates to true. So say Boolean 1 is a string. We could do that. If it's an empty string, then it'll evaluate to false. If it's a populated string, it'll evaluate to true. Similar thing for numbers. So 0 is always equivalent to false, and any number other than 0 is always equivalent to true. So those could also be stored in a variable like this. For now, I think it probably is the easiest to wrap your head around just the raw true or the raw false being stored in there, because that's all that's really meant to be the case in these examples that I'm using right now, just for the understanding of how Boolean expressions and conditionals work. So for now, just consider that the raw value true or the raw value false is stored in Boolean 1 or Boolean 2. All right, so the questions are, do we know in data that we are treating Boolean 1 or 2 to be sure what's true or false? So I don't want to spend too much time on what true or false is, because we did go over this last week in our lecture. So if you have any confusion about data types and operators, if you could review lecture 1, I think that would be really helpful. So remember, true and false are just, a Boolean is something that has a dichotomy, basically. A Boolean is either true or it's false. It cannot be any other value. So Booleans must be true or false, the data type Boolean, not these variable names. Variables can store anything. So true just means true, like it's like yes, and then false is like no. So that, like there is a very clear distinction between what is true and what is false, and a clear distinction between like yes and no, right? So it's a dichotomy type variable like that. Yeah, and again, like anything can be stored in Boolean 1 and anything can be stored in Boolean 2. These are just variable names. So if there's any confusion about variables as well, please review lecture 2 from last week, because that will clarify how variables are used. They basically just store data. All right, cool. So I'm not seeing any other questions in the chat, so I'm just going to keep moving along. But if there's any additional clarifying questions or anything, please throw them in the chat. All right, so don't worry too much about this slide. I just want you to know that it's out there. There are ways that you can create shorthand conditionals. So there's a shorthand if, where it's like a one-liner if statement. So if you could have if Boolean 1, then print Boolean 1 is true. So if whatever value is stored in Boolean 1 evaluates to true or is true, then Boolean 1 is true will be printed to the console. Don't do this, it's hard to read. Yeah, definitely don't do the shorthand if. Just know you might see it in other people's code. That's why I wanted to include it here. But this shorthand if else, this is a little more common. It's an advanced concept here. So don't worry about it. Just know that it exists. You'll find applications for it down the line. Trust me. This is something that I used to never use, but now I do use it pretty regularly. But don't worry about it right now. You can always do any of these shorthands. You can do it in one of the other examples that were used on the previous slide. Okay, cool. So in this particular case, we have like this value, Boolean 1 is true if Boolean 1 else Boolean 1 is false. So what happens here is you put what you want to happen in the case that your Boolean evaluates to true. And so you put what you want to happen there, and then you have your if, and then you have the Boolean expression that you're evaluating, and then you have your else, and then you have what you want to happen in the case that your Boolean expression evaluates to false. Again, don't worry too much about these shorthands. They're an advanced topic. The first shorthand here you just should never use because it's hard to read and it doesn't look good. And the one down here, you'll find applications for it down the line. I don't want to get too deep into the woods about exactly what those are right now. But yeah. So I'm not seeing any questions in the chat. And I realized on the last slide, I forgot to go back to Aziz, who had a question. Aziz, do you still have a question, or did maybe some of the questions from the last slide, did those answer whatever your question was? All right, here's hoping that whatever the question was got answered on the last slide. But Aziz, if you do have a question, please feel free to raise your hand or post it in the chat. Yeah, cool. So not seeing any other questions in the chat right now, so I'm going to keep chugging along. All right, so now continuing on with conditionals. Conditionals can also be nested, meaning you can add a conditional within another conditional. Just again, be mindful of indentation. So as I've mentioned a couple times now, you need to be very conscious about how you use indentation in Python. It's a very important syntactical element of the Python language. Many other languages use like curly brackets and things like that. Python doesn't. We just use indentation in Python. So be very mindful about how you're using your indentation. So in this particular case, we have if Boolean 1, and then nested under that if Boolean 1, we have another conditional where we have if Boolean 2, and this is an if else. So one thing that's great about PyCharm is there's these little gray bars here. And they might be a little hard to see right now, but these little gray bars here kind of call out what's related to this nested if. So there's this if, and then there's this else that's tied to this if up here. So this one's an if else right here. And then nested under our if Boolean 2, we have another if else. So we have if Boolean 3 and an else there. So and then down in our else block from our if Boolean 1 else, because this ties in right here. If Boolean 1 else, we have another conditional nested underneath there where we have if Boolean 4. So there's a bunch of different ways that we can go through this. So I'm just going to go through them pretty quickly. And if you want to review them, please watch the YouTube video once it's uploaded. But if you do have any questions as I go through, post them in the chat. So if Boolean 1, let's say Boolean 1 is false. So we evaluate this, Boolean 1's false. Because it's false, we skip everything that's nested underneath that. So we go straight to our else. And then we check if Boolean 4. Let's say Boolean 4 is true in this case. So Boolean 4 is true, then we print Boolean 1 is false, Boolean 4 is true, but who knows about Boolean 2 and Boolean 3? The reason nobody knows is because we never evaluated it. We only evaluate those within the if Boolean 1. But since if Boolean 1 evaluated to false, we just went straight to our else block. But if Boolean 4 were instead false, then we would come to our else here and we'd say Boolean 1 and Boolean 4 are false, but who knows about Boolean 2 and Boolean 3? Again, for the same reason, we just didn't evaluate Boolean 2 and Boolean 3 because we only evaluate those in the case that Boolean 1 is true. So now let's say Boolean 1 was true. So if Boolean 1 is true, then we come into here and now we're going to check Boolean 2. If Boolean 2 is false, then we come down here and say Boolean 1 is true and Boolean 2 is false, but who knows about Boolean 3 and Boolean 4? The reason we don't know about Boolean 4 is because we only evaluate Boolean 4 in the case that Boolean 1 is false, because we have to make it to the else block of Boolean 1. But let's say Boolean 2 is instead true. So now if Boolean 2 is true, now we're going to evaluate Boolean 3. So if Boolean 3, so say Boolean 3 is true. Then we'll print Boolean 1, Boolean 2, and Boolean 3 are all true, but who knows about Boolean 4? Again, we don't know about Boolean 4 because we only evaluated in the case that Boolean 1 is false, but Boolean 1 must have been true for us to make it to line 39 because we only go inside of this block right here in the case that Boolean 1 is true. But say Boolean 3 was false, then we go to the else block tied to Boolean 3, and we print Boolean 1 and Boolean 2 are true, but Boolean 3 is false, and who knows about Boolean 4? So I know that was a lot. If that was a little confusing or too fast, please take some time to go over it in the YouTube video that I'll be uploading after lecture. And yeah, so let's see, questions. Is it possible to use Boolean values in arithmetic operations so that their integer values will be used to return an integer value? So I guess I'm not too sure what you mean by using a Boolean value in an arithmetic operation. To use a Boolean value in arithmetic operations so that their integer values will be used to return an integer value. Maybe what you're getting at here is like using a Boolean style operator, like a comparison operator, like the equals operator, the less than, greater than operator, or something like that, with two integer values. In that particular case, that's still going to evaluate to true or false, even if the two values on the two sides of that comparison operator are integers, it's still going to return a Boolean. Yeah, it looks like maybe you're clarifying the question here. That would help a good bit. Let me read through it again. Is it possible to use Boolean values in arithmetic operations? Okay, I see what you're saying here. So you have like true plus true is equal to, because you're using the double equal sign, 1. So we can't do that. No, we can't add together, like we can't use an arithmetic operator with Boolean values. So you don't want to use the plus operator with two Boolean values like true. But something you could do is if you took off that true plus in the initial part, and you were just left with true equals 1, that is a perfectly valid Boolean expression, because you're assessing the equality of true to 1. And yeah, so that would be valid. It would result in a Boolean value, though. It's not going to result in an integer value. That would result in a Boolean value. Cool. I hope that helps to clarify your question there. Thanks for the question. If there are any other questions, please post them to the chat. I really like how this chat approach is going. Cool. I'm just going to keep moving along because we've still got a good bit to cover. Okay, so another follow-up here, but true equals 1 and false equals, and you use the ampersand there, which is the bitwise and false equals 0. So we can't do that, because what you would be doing there is you're using a single equal sign, which is the assignment operator, and true and false are reserved keywords in Python. So you can't use those as variable names. So what you have here is like you're trying to assign the value true, or you're trying to assign a variable called true the value 1, and a variable called false the value 0. And we can't do that because they're reserved keywords in Python. You would need to come up with different variable names there to assign 1 and 0 to those variables. And I don't know if it was intentional to use the bitwise and there between true equals 1 and false equals 0. But if so, like, I'm just going to reiterate what I had said last week. Don't worry too much about the bitwise operators. Bitwise operators get exceedingly complicated, and you're unlikely to use them, at least at the beginning of your coding journey. So if you want to learn more about them, you can definitely do some research about them, or email me, Fraj, Gaurav, and Zach about it. But for now, don't worry about the bitwise operators. So I'm just going to kind of conveniently ignore that part of it in case it was intentional, but I'm assuming that what you meant there is like trying to do assign true the value 1 and false the value 0, which again you can't do because true and false are reserved keywords in Python, or at least you shouldn't do. Theoretically you can, but you shouldn't. All right, I'm going to keep chugging along. All right, data structures. So let's see. A data structure is essentially a means for storing and organizing a collection of data values. Generally, data structures are composed of primitive data types, such as strings, Booleans, and numeric data types, but they can include other data structures nested within them. Each has their own set of methods or a defined action that can be performed on that data structure. Methods are called on a data structure using dot notation. And an example of that here is like our data structure. So say I had a data structure stored in this variable, which I've called data underscore structure, because remember, we can't have spaces in variable names. So I have a variable data underscore structure, which is storing a data structure in it. And then I want to call it some method that's part of that data structure on that data structure using dot notation. So this period here is the dot notation. So I have my data structure variable name, dot, and then the method name followed by parentheses here. So these parentheses are very important because that makes it actually calling the method instead of just referencing the definition of the method. So there are many different kinds of data structures, each with their own relative benefits and uses. So we have sets, tuples, arrays / lists, dictionaries, objects, and the list goes on. You can actually create your own data structures in Python. We're not going to cover that. We're just going to cover some of the basic data structures in Python. But yeah, any questions on what a data structure is in general? Not seeing anything in the chat, so I'm just going to keep going along. Cool. All right, so we're going to start with sets. So sets are an unordered collection of unique values that are immutable. So we're going to go through each of those italicized words in turn here. Unordered. The elements within a set are not ordered. You can enter them in any order when creating the set, but the order is not maintained. So here I've created this set one and use it, and set notation requires like these squiggly brackets. We'll get to that down here, but we're creating a set with these squiggly brackets. So I have 1, 4, 6, 8, 9, 3, 5, 54, 7, 8. I put them in that order when I defined it, and what was echoed back to me in my REPL environment is 1, 3, 4, 6, 7, 8, 9, 54. So this did not maintain the order. Sets don't maintain their order. They are an unordered collection of elements. They're unique. So all the elements in a set must be unique. Duplicates are not allowed. So if I try to create a set here with 3 1s, 3 2s, 3 3s, and 3 4s, what's echoed back to me is just 1 1, 1 2, 1 3, and 1 4. And something that might help here for those with a math background, sets are the same. Sets in Python are basically the same as sets in math. So with a set in math, you can't have duplicate values in it. Sets are unordered collections of unique values. So you try to add multiple ones to a set in math, and it just results in a single one being in that set. They're also immutable. So what immutable means is that once it's defined, you cannot change the values of the elements in the set, but you can add and remove elements from the set. So I created a variable called my underscore set, and I assigned it the value a set containing the numbers 1, 2, 3, and 4. So the elements in my set are 1, 2, 3, and 4. And notice they're separated by commas. That's how we separate the values of our data structures typically. And we used our squiggly brackets to identify that it's a set. Now when I just kind of output my set, so since I'm in the REPL environment here, which you can tell by these 3 green arrows, since I'm in my REPL environment, I just type in my set, hit enter, and then it's going to output the value of my set back to me. So my set does contain the set 1, 2, 3, and 4. Here I can call the add method on my set using dot notation, and pass into that as a parameter the value 5. So here I take my set and I call the add method on my set using dot notation here. So I do my set dot add, and then I have my parentheses after it. And then in the parentheses is the value that I want to add to my set. So here I want to add the value 5 or the element 5 to my set. So now 5 has been added to my set. I output my set again in the REPL environment. Note that this won't work in a typical text, like in a typical .py file. This only works because I'm in the REPL environment. If I was in a .py file and I wanted to see this value output at the console, I would have to print it anyway. So now that I output it in my REPL environment, now my set contains the value 5, as well as 1, 2, 3, and 4, like it did up here. And now say I want to remove the value 3, so I can use the remove method. And the way I use that remove method is calling it on my set using dot notation. So I do, my set dot remove, and then the parentheses after it, and the parameter that I pass to my remove method is the value 3, because I want to remove the value 3 from my set. And now when I output my set again, 3 is no longer in my set. But there's not a way for me to change the individual elements of this set. So if I wanted to change like 3 to 5 here, which is essentially in a way what happened with these two operations, I changed the 3 to a 5. I have to do it in this way by adding and removing. I can't reference this individual element of 3 in my set and reassign its value to 5. That's not possible to do with a set. And we'll see other data structures where it is possible to do that. And then it might make a little more sense as to how this is immutable compared to a mutable data structure like a list. So we can define sets in one of two ways. So we can do my set equals set. We can use the set constructor here. So you would just use the word set and then parentheses after it. And now stored in here is a set. It's an empty set, but a set nonetheless. Or we can do my set equals just the squiggly brackets here. And then what's stored in my set is an empty set. So that's the value that's now stored in the variable my set. Something to call out here. It's always better to define your sets using set notation or using the constructor, especially when you're starting out with an empty set. The reason for that is these squiggly brackets are actually used for another data structure as well. So this line here, my set equals the squiggly brackets, that is actually very confusing to a Python developer. I guess it's not terribly confusing because I used good variable names, so it's obvious that it's supposed to be a set. But to me, if I came into code and I found, some variable, some random variable name, say they just called it X for whatever reason, and then they said X equals these squiggly brackets, I don't know if they meant for this to be a set or a dictionary, because dictionaries also use squiggly brackets. They just have different data structures within them, and that's what separates sets from dictionaries. So especially with sets and dictionaries, it's generally better to create them using the constructor up here, unless you're going to add values to them immediately. So here I populated it with values immediately. So this made it obvious that it's a set, where I did my underscore set equals squiggly bracket 1, 2, 3, 4, closing squiggly bracket. That makes it obvious it's a set, because a data structure is a dictionary is a key value pair, whereas sets is just like a collection of individual elements. So if you're creating your set and immediately populating it with values, it's okay to define it this way. But if you're starting out with an empty set and then you're going to go and add and remove variables and things like that as you go, create that set using the set constructor here. All right. So let's see, questions in the chat. So someone said data structure, and then they have strings with the square brackets. I guess I'm not sure if that's just like a question or kind of a comment on like maybe some data structures you've seen in other languages. Yeah, if there's a question there, if you could please clarify, that would help a lot. But it kind of looks like maybe you're just referencing something that you remember from a different programming language. So, all right, another question. Is it possible to add or remove elements inside the set by calling them with an index? Great question. No. You can't do that with a set. Sets are not indexed. They're unordered. So there's actually no way to know which index, like, when I created this one up here, I have 1, 4, 6, 8, 9, 3, 54, 7, 8. There's no way to know what index the value 9 is at, because they're unordered. So once I output that set here, it's immediately like it's immediately in a different order. So there's no concept of indexes in sets. And that's one of the reasons why they're also immutable. You can't reference an individual element in a set using its index. And for those of you who are confused about what an index is, we'll get to it. Don't worry. That's more important with arrays and lists and things like that. But yeah, for those of you who do have experience with coding with a set, you cannot reference individual elements using an index. Great question. How do we populate a set defined with set? So great question. So if we created my set equals the set constructor, the way we would add values to that, the way we would populate it is using the add method here. So we would call my set dot add, and then we would add the values we want, and then we would put the value we want to add to our set within the parentheses there. And that's how we would populate an empty set, an initially empty set. Great question. So is it possible to use lists inside the set? I believe, yes, that you can have lists inside of a set. So one of these elements could be a list. There are certain data types or data structures that cannot be nested within a set because they aren't serializable. So you'll see those, but don't worry about it too much right now. Generally, though, you can store most data structures within a set. They can be the individual elements of a set. And then a comment here, I would like you to encourage those who have the background to also give a helping hand. Yeah, if anyone does have a background in programming, and there are some questions in here that you think you're well equipped to answer, please do. Please add it in the chat, and that would help me out a lot. The way I explain it is just one way to understand it. And there's a bunch of different ways that people could go around understanding how these concepts work. So different perspectives are always valuable. I try to talk about it in a number of different ways, but I'm not going to capture everybody's learning style here. So yeah, so if anybody else has ways that they think would be helpful to explain it, please throw that in the chat. I think that would be great. All right, so another question. So we add a single element at once with set. Yeah, so you can add a single element at once. There's other methods. There's other set methods where I believe you can add multiple elements to the set in a single method. You could also, another thing you could do is you could start out with this set constructor, and passed into the parentheses here, you could pass like a list of values. We haven't talked about lists yet, so that's why I haven't really gone over that. But like, say we had a list, we could pass that list as a parameter to the set constructor, and it would convert that list to a set. So that's one way that you could populate it with multiple values at once and just have it populated immediately from the get-go using the set constructor. Great questions. How can we add one element in front of this set? How are we going to do it? So you actually can't do that. So because sets are unordered, you can't decide where the value goes in the set. So, we have this set 1, 2, 3, 4 here. I can't add a value in front of 1 because there's no order to this set. There's actually no concept of 1 comes before 2, which comes before 3, which comes before 4. Python happens to sort them when it outputs the set, but in the back end, there's actually no ordering to this set. So we can't put a value in front, like at the very front of the set. There's just no way to do it. And that's because sets are unordered. There are other data structures where you would be able to do something like that, such as a list. And we'll get to those. But for now, we're only covering sets. But yeah, awesome questions, everybody. I'm loving them. Keep them coming if you have them. But that looks like it's the last one for this slide, so I'm going to keep moving along. So set methods. So here are 3 set methods. So there's the add method, which we saw. So the add method adds a specified element to a set, and we saw that on the previous slide. So here, say we start out with my set is 1, 2, 3, 4. And I'll cover this is stuff here. This is something I had mentioned that we would cover last week in this lecture. So here we start out with my set is 1, 2, 3, 4. Here I take my set and I add the value 5 to it. And then let me actually just go back to the previous slide for that. So for the add and remove method, remember we started out with my set 1, 2, 3, 4. So the values stored in it are just 1, 2, 3, 4. And then here I call my set, and I call the add method on my set using dot notation, and I pass in the value 5 and add it to that set. And now 5 is in my set. And then the remove method removes an element from a set. So we have my set dot remove, and we're going to remove the value 3. So now 3 no longer exists in our set. So that's how that one works. And now the copy method returns a copy of the set. So last week, we had talked about the is operator, which is one of our identity operators. The is operator becomes very important with data structures. So in this case, I have my set is equal to 1, 2, 3, 4. Now I say your set is equal to my set. So now what I've done is stored in your set is the same exact set as my set. It's the same exact set in my computer's memory even. So now when I check your set is my set, that evaluates to true. Because your set is in fact my set. They are the same exact values in the memory of my computer. So that evaluates to true. Now if I take my set and I add the value 5 to it using dot notation, so I do my set dot add, and I pass in the value 5. Now when I output your set, notice how 5 has been added to your set. Initially, your set only had 1, 2, 3, 4, just like my set. Now your set contains 5. This seems like really weird behavior, right? Like you start out with, I created your set and I set it equal to my set. Then I added something to my set and now your set also contains that value. That's because they are the same exact element in the memory of my computer. So they're the same exact data structure. So if I do something to my set, it also does it to your set. But now, maybe that wasn't the behavior you wanted. Maybe you actually wanted a distinct copy of your set that isn't going to be modified as I modify my set. That's where the copy method comes in. So in this case, if I take your set and set it equal to my set dot copy, so I'm calling the copy method on my set using dot notation. What's returned here is a copy of my set. And now we store that in your set. Now when we check your set is my set, so we're checking is your set my set? They aren't. They are no longer the same exact data structure in the memory of my computer, so that returns false. The values stored in them are equivalent, but the actual object in memory, the bits on my computer that are storing this, they aren't the same. So that returns false. Now, if I take my set and I remove the value 3 using the remove method, so I call the remove method using dot notation on my set. So I have my set dot remove. The value 3 is passed into the parentheses here. Now, when I output my set no longer contains the value 3, and when I output your set, it still does contain the value 3 because your set was a copy of my set. It wasn't the same exact thing as my set. So this is where the identity operator comes in. It becomes very important with data structures, and generally with data structures, you can create a copy as opposed to a direct assigning so that you don't accidentally modify both variables if for whatever reason you did want to have two distinct variables, two distinct objects in memory, basically is how I should put it. Yeah, cool. I'm sure there are some questions on this. Okay, I think set does not have any indexing method, so we are not able to know the position of elements. Yep, you're exactly right. And thanks, Abraham, for answering that question. That's exactly right. Yep, there's no indexing, so no way to know the position of the elements. It is an unordered data structure. So, there's no concept of 1 coming before 2 or anything like that. Okay. So do you mean a set created by placing all the items in elements? So you might have heard me use the term, so you have heard me use the term elements for a set. Each individual item that's in a set is called an element. And that's just something I'm kind of borrowing from math because sets are composed of elements and all that stuff. But yeah, so that's exactly right. A set is created by adding all the elements to that set. Cool. Not seeing any other questions. I guess I'm sure that somebody has a question about the is operator and the whole difference between direct assigning versus assigning to a copy. So if you do have that question, please add it in the chat. Remember, if you have a question, chances are somebody else has that same exact question. So, you're helping yourself and other people out by asking that question. But for now, I'm just going to keep moving along. All right, more set methods. So these come in as basically like part of math. So if you have a math background, this might help understand how these methods work. So there's the difference method. The difference method returns the elements in one set that are not in another. So I have my set 1, 2, 3, 4. And I call the difference method on that set using dot notation. So I have my set dot difference, and then in the parentheses for that, remember the parentheses are important. In the parentheses, the parameter I'm passing is another set because I want to get the difference between this first set and the second set. So what's returned are the elements that are in the set on the left that are not in the set on the right. So notice here, 1, 2, 3, 4 is in the set on the left. 3, 4, 5, 6 is in the set on the right. 1 and 2 are the only values that are in the first set that aren't in the second set. So we get a subset of 1 and 2 returned there. So that's what the difference is between these. Note we could flip this. If we flipped this, if we had 3, 4, 5, 6 up here, and then we had 1, 2, 3, 4 as the parameter that we passed to the difference method, then this would evaluate to a different, this would give us a different response here. What it would give us is 5, 6, because 5 and 6 are what are in this set that's not in this set. But something important to note, basically what I'm trying to get at here is that when you call the difference method, you're checking what's in the first set that's not in the second set. It doesn't matter if there are any extra elements in the second set that aren't in the first. What really matters is the elements that are in the first set that aren't in the second. Those are the elements that are returned in a subset. All right, intersection. So set intersection returns a set containing the common elements of 2 or more sets. So this is kind of like the opposite of difference, right? We're looking for the values that are the same between these two. So we have the same 2 sets, 1, 2, 3, 4, and 3, 4, 5, 6. And we're going to call on our set that contains the elements 1, 2, 3, 4. We're going to call the intersection method using dot notation. So we have our 1, 2, 3, 4 set dot intersection, and then we have our parentheses here. And in our parentheses, we pass as our parameter the set 3, 4, 5, 6. And what we're going to look for here is common elements between these 2 sets. The only common elements between these two sets are 3 and 4. So what we get as our return value is a subset containing the values 3 and 4. So that's how an intersection works. It's basically looking for the common elements between the 2 sets. Now a union. Union returns a set containing all of the unique elements present in 1 or more sets. So in this particular case, what it's basically doing is it's taking 2 sets and combining them. So we have our first set, 1, 2, 3, 4. We call the union method on that set using dot notation. So we have our first set of 1, 2, 3, 4 dot union, and then our parentheses. And in our parentheses, we pass the parameter 3, 4, 5, 6. So now what we do is we basically combine these 2 sets together, and we end up with 1, 2, 3, 4, 5, 6. Something you'll notice here is that we don't see, even though both sets contain the value 3 and 4, in the output set, we don't see 3 repeated and 4 repeated. The reason for that is, again, because the elements must be unique within a set. So you can't have duplicate elements within a set. So even though, you might think combining these would result in 2 3s and 2 4s, that's not the case. We just get 1, 2, 3, 4, 5, 6. There are a bunch of different set methods out there. Too many for us to cover in a lecture. So check out this link here. I will be sending out the slides along with the YouTube recording of this lecture. So check out this link if you want to learn about more set methods. Yeah. Let's see, a question. Please, them once, sir. So I think what you might be asking is just going over them once again. If that's not the case, please clarify in the chat. But yeah, I can go over these once again. So difference, set difference returns the elements in one set that are not in another. So it's set difference will return the elements in the set that's on the left that aren't in the set on the right. So this returns 1 and 2. Intersection returns a set containing the common elements of 2 or more sets. So in this case, we look at what are common between the sets on the left and the sets on the right. So that gives us 3 and 4. And then union returns a set containing all of the unique elements present in 1 or more sets. So we have 1, 2, 3, 4 unioned with 3, 4, 5, 6. So the resulting set is 1, 2, 3, 4, 5, 6 because we combine those 2 sets. And again, we can't have duplicates. So 3 and 4 won't be duplicated. And if the question was to go over the set methods that are in this link, unfortunately, we don't have time for that. There's just too many methods to cover, but please do check them out. And if you have any questions on them, ask them on the YouTube video and I'll be happy to answer them there. All right, the in operator. The in operator can help us to determine if an element already exists in a set by using it to form a Boolean expression. So say I have a set. This is a set of string values. So the string values in this are David, Matthew, Eric, and Sean. I can check if David is already in that set by doing the string David in my set. That returns true because David is in fact in my set. But what about Josh? Is Josh in my set? So I want to check Josh in my set. That returns false because Josh does not exist in this set. So the in operator is super helpful for understanding whether or not a value is already in a set or just about any data structure. It can be used in one way or another for many data structures. Yeah, so highly recommend the in operator for understanding if an element is in a set or is in a data structure in general. Cool. Any questions on the in operator? Not seeing anything in the chat right now, but if you have any questions on it, please do add them to the chat. But yeah, in operator is just super helpful for identifying if something's in a set. Like a great example here is, say you have a set of like student names or something, and you want to know a student names for a specific class. You want to know if some student is in that class. You can easily do that with the in operator. Cool. So additional resources. I cannot recommend enough taking the time to go through these additional resources. Please, please, please do. It'll help clarify a lot of the questions you have and give you some actual like hands-on experience with some of these things. So the first link here is for conditionals. There are exercises for conditionals at the bottom of the page. This second link is a link on sets. This will talk about all the different set methods that I wasn't able to cover, as well as the ones we did cover. And then here's a link to exercises on sets so you can get some hands-on experience with sets and all that good stuff. Great. And it looks like a comment in the chat. Today's class is straightforward, even though I joined late. Glad to hear that the class was straightforward. And yeah, no problem that you joined a bit late. Just check out whatever you missed in the YouTube video that I upload to that I send out later. It looks like we have a question. So only string is allowed on in. Great question. No, that is my mistake. Thanks for calling that out. So strings, so any value can be used with the in operator. So say I had a set of like Boolean values. So it's like just the set of the two Boolean values, true and false. I could then say like true in my set, and that would have like return true, things like that. So you can do Boolean values, you can do integers, whatever it might be. In this particular case, it just made sense to use strings because I'm kind of imagining my set as something like, a list of like students or something like that. So that's just why I use strings here. But great question. You don't need to use strings with the in operator. And the other question is, yep, I will be reviewing. Oh, sorry. We won't be going over the answer to assignment 2. That is because assignment 2, we still need to finish grading. There's a number of people who haven't gotten their grades back for assignment 2. And for those of you who didn't get a passing grade on assignment 2, on the first iteration, you will be able to, you have another week to get a passing grade on that. So be looking out for feedback that if you haven't gotten it already, we'll be sending it out later today. And then thank you. I'd like to confirm our assignment. How do we know we did it right before the next class? So yeah, again, we'll be getting around to responding with feedback for assignment 2 momentarily, basically. I'm going to be working on that right after this lecture. Great. All right. So as for assignment 3, so assignment 3, so your assignment that's due, at least your first attempt is due by next Saturday. We have an activity suggestion app. Your client is extremely indecisive with what to do in their free time and wants you to develop a simple program to make suggestions as to what they could do based on a few factors. This program should be able to store, and again, when I say store, think variables. It should store a weekday indicator, whether or not it is a weekday. This should be a Boolean value. The current weather, this should be a string value. The funds the user has available to spend, and this should be a numeric value. The client lives in a place where the weather is always either nice, raining, or freezing. So the program should verify that the weather entered matches one of these values. Hint, use a set along with the in operator. After verifying that the weather entered is valid, the program should do the following. In the case that it is a weekday, the program should output a reminder stating, you may have work or school today, but here are some suggestions if not. Then, in the case that the weather is nice, the program should output, the weather is nice, so let's do something outside. Then, in the case that the user's available funds are at least 100, the program should output, let's go to an amusement park. Otherwise, the program should output, let's go for a walk in the park. And then otherwise, and this otherwise goes with this then up here. So otherwise, in the case the weather is raining, the program should output, it's raining outside, so let's do something indoors. Then in the case the user's available funds are at least 50, the program should output, let's go to a museum. Otherwise, the program should output, let's stay in and watch movies. And this otherwise, again, goes with this then and this otherwise and this otherwise. So otherwise, the program should output, it is freezing outside. If you leave the house, make sure to bundle up. Then in the case the user's available funds are at least 150, the program should output, let's hit the slopes and go skiing. Otherwise, the program should output, let's stay in and drink hot chocolate while watching movies. And then otherwise, and this otherwise is in the case it's a weekday, otherwise the program should output, it's the weekend, woo, let's decide what to do. Then in the case the weather is nice, the program should output, the weather is nice, so let's do something outside. Then in the case that the user's available funds are at least 100, the program should output, let's go to a concert at an outdoor venue. Otherwise, the program should output, let's go on a hike somewhere. Then otherwise, and again, this otherwise goes with this then up here. Otherwise, in the case the weather is raining, the program should output, it's raining outside, so let's do something indoors. Then in the case the user's available funds are at least 50, the program should output, let's go to a comedy show somewhere. Otherwise, the program should output, let's go on some free tours of the local places of worship. And then otherwise, and this otherwise goes with the weather otherwise. So otherwise, the program should output, it is freezing outside. If you leave the house, make sure to bundle up. Then in the case that the user's available funds are at least 150, the program should output, let's check out a local bar and or arcade and play some games. Otherwise, the program should output, let's just call some friends and see if they want to come over and play board games. So quick hint about this assignment, and this is very important. So it will help you a lot. The way I've nested these bullets are exactly in line with how your conditional nesting should look. So you can kind of think of it like this. In the case it's a weekday, and then this otherwise, that's one conditional. So that's like your outermost conditional, your outermost if else. And then in here, anytime you see then, you can kind of think of it as if. Anytime you see otherwise, you can think of it as else. But if there's a in the case following that otherwise, then it's an elif, and then your otherwise is kind of an else. So giving you a huge hint here on how to interpret this assignment and how to translate basically what I have into what I'm looking for here, which are conditionals. Cool. You're going to be using comparison operators and all that good stuff within your Boolean expressions. So yeah. Great. I'm not seeing any questions on the assignment in the chat. So hopefully that's very clear. I will be recording. So I recorded this lecture. I will be uploading it to YouTube, and I will also be sending out the slides and the assignment to you all. Yeah. So that's I think it for this week. Any questions from anyone? It looks like we do have a hand up. Sorry if this has been up for a while. Hader, do you have a question?
Yeah, teacher, can I ask you a question?
Yeah,
Sorry,
absolutely.
actually, it may be like personal. I will be very happy because of like a travel to some country. I didn't manage to get you early in the sessions. So if it is that okay, maybe we can. Is that okay to start after 1 hour? Maybe. Just I don't want to miss any point of your class.
So unfortunately we have to keep the class time at this current time because this is what we've found through research in the past works for most people. But the lectures will be uploaded to YouTube. So anything you missed, if you're unable to attend the lecture, you can go ahead and just watch the lecture on YouTube. And then in order to get participation credit, you just have to add a few things that are present in the syllabus as a comment to that YouTube video. Yeah, unfortunately, we can't change the time of the lecture, but but yeah, you do have other options. If you're unable to attend the lecture, you can watch it on YouTube and then comment a few things on that YouTube recording in order to get participation credit. Is that helpful?
Thank you very much. Yeah.
Awesome. Glad to hear it. Thanks for the question, Hader.
Okay.
So it looks like so can we have corrections for some assessment? So after it's been 2 weeks since all the assignments and everyone's either gotten a final pass or fail on an assignment, we can send out solutions for the assignments, but we're only going to send that out to people who have actually tried on the assignment. So if you just like never submitted anything, we are tracking this. If you never submitted anything, you won't get the solutions for the assignment because we need you to try first. But yeah, after next week, we can send out the solution to because that's when the final thing is due for assignment 2. After next week, we can send out the solution to assignment 2 to those who actually attempted the assignment. Yeah, we can definitely do that. Please remind me about that next week. Thanks, Aziz. Another question for the assignment: when it says store for a variable, do we assign a random value or get an input? Great question. You don't need to worry about inputs right now. We haven't covered IO yet, which IO stands for inputs, outputs. So don't worry about getting user input. If you know how to do that, great, go ahead, you absolutely can, but it's not a requirement of the assignment. You just need to store a raw value. You can just come up with a random value. Just make sure it fits in with what's defined in the assignment, whether or not it's Boolean or string or things like that. But yeah, you could use user input. It's going to complicate things for you if you use user input, but we haven't covered that yet, so we have no expectation of you using user input. Cool. So do we have one more week for those of us who didn't submit assignment 2? So unfortunately, if you haven't submitted assignment 2 by now, that results in an automatic fail. Remember, and this is something that we all agreed to by the syllabus, is you need to at least submit your first attempt by the following lecture. So this goes for assignment 3 as well. You need to submit your first attempt on assignment 3 by our lecture next week. If you don't, that's an automatic fail. And I know things come up. If things come up, please email us. Email us and explain the situation, and we are more than happy to make exceptions here and there. I totally understand that life comes up, but we also need to make sure that we're managing our workload for the course, basically. And if we just kind of let assignments be submitted as as late as it's, I guess, convenient for everybody, then we're going to end up doing a lot of back grading and all that stuff when we're trying to keep up with the grading of the existing assignment. And these are all things that were outlined in the syllabus. If you haven't read the syllabus yet, please take the time to read it. It's these things do have these rules do have important impacts on the outcomes of the course for you. But note that even if for whatever reason you didn't submit the assignment 2, that you only need to get a passing grade on 80% of assignments in the course. I believe there are 11 assignments overall, so that's like you need to get a passing grade on like 9 of the assignments, basically. So it's not going to be like the end of your ability to get a certificate of completion just by missing one assignment. So hopefully that's helpful as well. All right. So I think that's it. I don't see any other questions in the chat. I hope you all have a great rest of your weekend and an awesome upcoming week. And I will talk to you all next Saturday. Have a good one. Thanks. Bye.